We're going to use the definition of the derivative to differentiate f of x equals x squared minus 1 divided by x squared plus 5. So recall the definition of the derivative. F prime of x is defined by the limit as h approaches 0 of f of x plus h minus f of x divided by h. We're going to do this in steps. First step is to compute and simplify f of x plus h. So we're going to replace every x we see in this function with x plus h, and we'll use parentheses. The first x is in the numerator. We'll replace it with x plus h and then square the whole thing minus 1, and similarly in the denominator that is x plus h squared plus 5. Now let's go ahead and expand this. X plus h squared becomes x squared plus 2xh plus h squared minus 1 in the numerator, and in the denominator we have similarly x squared plus 2xh plus h squared plus 5. This is the end of step 1. There's nothing more that we can do here. Step 2, we take what we did in step 1, that is f of x plus h, and subtract f of x, and that's equal to x squared plus 2xh plus h squared minus 1 divided by x squared plus 2xh plus h squared plus 5, and we're going to subtract f of x, which is x squared minus 1 divided by x squared plus 5. Now we're going to now combine these two to have a common denominator. The goal of step 2 is to factor out an h. At the end of step 2 we want to factor out an h. The common denominator will be the product of these two denominators. Then to do that we'll multiply the numerator on the left by x squared plus 5 and the numerator on the right by x squared plus 2xh plus h squared plus 5. So let's see what that looks like. This is equal to, we have x squared plus 2xh plus h squared minus 1. All of that will be multiplied by x squared plus 5, and from this we subtract x squared minus 1 times x squared plus 2xh plus h squared plus 5. And our denominator is the product of the two denominators, which is x squared plus 2xh plus h squared plus 5 times x squared plus 5. There's no need to do anything with the denominator until the very end. We have to work on the numerator. So let's go ahead and multiply through. We have x squared times x squared becomes x to the 4th. X squared times 5 is 5x squared. 2xh times x squared becomes 2x cubed h. 2xh times 5 becomes 10xh. H squared times x squared is exactly that, x squared times h squared, and h squared times 5 is 5h squared. Now we have to multiply by 1, by negative 1, that's minus x squared and minus 5. And then minus, we'll do the same thing, x squared times x squared is x to the 4th. Make sure you put that in parentheses. And x squared times 2xh is 2x cubed h, and plus x squared h squared plus 5x squared, and then minus x squared minus 2xh minus h squared and minus 5. And of course all of that is divided by the the denominator that you see here, which is x squared plus 2xh plus h squared plus 5 times x squared plus 5. Now look at the numerator. A lot of things, many things will cancel, starting with x to the fourth cancels with x to the fourth. Here is 5x squared minus 5x squared over here cancel. In fact, 2x cubed h also has, there's a term when we're subtracting 2x cubed h, so we can cancel that. And then we have negative x squared here minus a minus x squared here, minus 5 minus a minus 5 also cancel. And let's see what we have left. We can also cancel h squared x squared minus x squared h squared. Those are all, the same terms. And let's look what we have left. We have 10xh that's left right here, and also plus 5h squared. And then minus, we have minus 2xh here and minus h squared here. So let's combine them carefully and see what we have left in the numerator. It will surely be a lot simpler than what we had before. We have 10xh minus a minus 2xh gives us 12xh. And then we have 5h squared minus a minus h squared. That gives us 6h squared. And all of this is divided by x squared plus 2xh plus h squared plus 5 times x squared plus 5. Remember, the goal at the end of this step is to factor out an h, and we can now do that. In the numerator, h comes out. We have 12x plus 6h, and this is divided by x squared plus 2xh plus h squared plus 5 times x squared plus 5. And that's the end of step number 2. In step 3, we take the end result of step 2, which is f of x plus h minus f of x, and divide that by h. Once we factored an h out in the previous step, that becomes a lot easier. So this is h times 12x plus 6h divided by x squared plus 2xh plus h squared plus 5 times x squared plus 5, and all of that divided by h. Now you can probably tell that h's will cancel. I want to briefly go over an algebraic rule why that happens. When we have a divided by b divided by c, that's a divided by b, and then we can write it like this, divided by c. That's a over b times 1 over c, which is a divided by b times c. So this h can slide right there next to the product of those two terms. And let's rewrite that. And that's equal to, after we simplify, that's equal to h times 12x plus 6h and divided by h times x squared plus 2xh plus h squared plus 5 times x squared plus 5. So we can now cancel the 8 h's. That's the goal of step number 3. We should always try, if possible, to cancel the h's, and what we have left is a simpler expression which we can now evaluate to give us the derivative. So the end of step number 3 is 12x plus 6h divided by x squared plus 2xh plus h squared plus 5 times x squared plus 5. And that's the end of step 3. Now let's go to step 4, where we can compute the derivative. The derivative in step 4, recall, is defined by the limit as h goes to 0 of f of x plus h minus f of x divided by h. So in this case, this becomes the limit as h goes to 0 of 12x plus 6h divided by x squared plus 2xh plus h squared plus 5 times x squared plus 5. Now remember, h is going to 0, not x. So this term 6h, that's going to 0. 2xh is also going to 0, and so is h squared. Everything else stays the same, so this is equal to 12x in the numerator, and in the denominator we end up with x squared plus 5 times x squared plus 5, which simplifies to 12x divided by x squared plus 5 squared. And to summarize, if f of x is equal to x squared minus 1 divided by x squared plus 5, by definition of derivative, the derivative of that function right here, f prime of x, is equal to 12x divided by x squared plus 5 squared. For more videos, visit www.mathprepvideos.com.